In this video, we are going to learn another differential rule called the chain rule. The chain rule is used when you have a function that is composite. So f of g of x or g of f of x. So we are going to be kind of doing practice rounds of recognizing a function into a two different composite function and then differentiate. Just like last section, we need to write down the whole function into the two products or the top and bottom. Same thing, we are going to come up with one big function and then rewrite that as a two separate composite functions. So let's recall what was composite function. In algebra, we learned that a function f is a composite of two functions g and h if f of x can be rewritten as g of h of x. In other words, this was symbol that you are familiar. F of x is g of h of x. So that's equivalent. Okay. The domain of f is a set of all x such that x is domain of h function and it's the domain of g. So if the function can be written as a composite function, then we apply the chain rule. You notice that this is a composite function is not a product. Do not confuse with the last section. It's a function within a function. Okay, so last chapter was two different functions being multiplied. This is a function. There's an inner function into the outer function. So the chain rule for the composite function goes like this. If f of g is equal to g of h of x is a composite function, then f prime of x is g prime of h of x times h prime of x. So notice we have kind of like another composite function going on. We first take the derivative of a g function and then put that into h and then take the derivative of that inside function and multiply. Provided that both g prime function and then h function exist. Equivalently, if you're used to the notation dy dx, this can be rewritten as, you see the two things being multiplied here. dy du, so this will be dy du, and then this will be du dx. So let's do 5 problems. And then the last one is application problem. So first, when I see this one, I'm going to rewrite my f as a g and h. Okay, and then take the derivative and then use the formula to plug it in, just like we did it with the product and chain rule. So how can I rewrite this f of x as g of h of x? So that means I need to come up with the g function and then h function. So h is an inner function. If you look at the definition, it's inside of some bigger one. So I'm looking at this. Oh, I kind of have this function inside of the parentheses of this 7th power. So I know that this is going to be a good choice for my h of x. So let's write it out. I have g of x and then h of x, and I'm gonna let this as an x cubed plus 4. Then where do we plug it in? Well, that's like kind of outside function. We plug it into this to the 7th power. So that will be something to the 7th power. Now let's check, since this is our first one. If I do f of x as g of h of x, will I get that x cubed plus 4 raised to the 7th power? Well, plug it in this h. Plug it in the h function into this inside of the g, so that means I plug it in. We get, so if I plug it in this one, I do get x x cubed plus 4 to the 7th power. So that's good. So that means I identify g and h correctly. Now I'm going to take the derivative. That means I need to take the derivative of a g function and h function. So let's first do that. G prime of x is 7x to the 6th power. H prime of x is 3x squared plus, well, actually 3x squared because constant disappear. So now here's my formula. Right? Here's my formula. Let me erase this part so we have a little bit more space. I'm also going to erase this extra. So always write down the formula because it's nice. So we just have to plug it in. Well, I'm plugging in this h into the g prime function. So notice I'm gonna composite this one. So that means I plug it in h of x inside of this g prime of x. So that means I have 7 instead of x. I put this whole h of x, which is x cubed plus 4 to the 6th power, and then multiply h prime of x, which is 3x squared. You can multiply these two, so final answer 21x squared, x cubed plus 4 to the 6th power will be my final answer. Okay, so come up with g function, h function. So when you compose it, you get the original. And then take the derivative for each one and then plug it into the formula. Okay? So as we get to practice each example, you're going to feel a little bit better each time. Okay? So let's do a couple more. Same thing. This y is my f. I need to come up with g and h. So my f of x is g of h of x. Okay. So h is my inner function. So again, whenever I see the parentheses, that's a good one to use it as a h. We have this inside function into this outer function of 6. Don't forget the 6. 6 times whole thing to the 6th power. So my intuition tells me again, h will be what's inside of the parentheses. And I'm going to plug it into this bigger function 6 something to the 6th power. So 6x raised to the 6th power. And if you compose it, you do get the original. So that's good. Now let's take the derivative g prime of x, which is, you bring down the 6 here, so 36x to the 5th. H prime of x, this is just term by term, so 2x minus 3. Now, from previous one, we know the formula, f prime of x will be g prime of h of x times h prime of x. So let's plug it in. H goes into this g prime function, so that will be the first one. So that means 36 times x squared minus 3x plus 12 raised to the 5th power. H prime of x is right over here, 2x minus 3. Now this is fine too. This is perfectly fine. Or you can simplify a little bit more by rearranging these terms. Rearranging is okay because multiplication is commutative property. And you can distribute this. So 36 times 2 x, which is 72x minus 36 times negative 3 will be negative 108 times x squared minus 3x plus 12 raise it to the 5th power. This will be also fine too. Now I wouldn't really FOIL that 5 times. That's fine. You can just leave it as x squared minus 3x plus 12 raise it to the 5th power. Okay. All right, let's do a couple more. Now take a look at number 3. Now number 3 does not have a parentheses, but you can kind of see that there's also another like inner function. This 2x squared minus 3x got put it underneath the cube root. So what got put it? So h is put it into the g function. So I'm gonna have good way. I like to always identify what is my inner function. 2x squared minus 3x got put it into cube root function. You can also rewrite the cube root as x raised to the 1/3. We like rewriting the root as a power so we can apply the power rule. So that's the first step. Rewrite f of x as g of x and h of x. Okay. All right. And then let's keep going. So we have g prime x will be 1/3 x. We subtract 3 over 3, another word, 1 whole, which is negative 2/3. H prime of x is 4x minus 3. Now let's get the formula. F prime of x is g prime h of x times h prime of x. So h gets put it into a g prime function, this whole thing. So 1/3 2x squared minus 3x raise it to negative 2/3 times 4x minus 3. Let's do a little bit of a rearrangement. I can rewrite this negative power as a positive power by moving it down, and then 3 is underneath. So you can write it this way, 2x squared minus 3x raise it to 2/3 times 4x minus 3. Or you can write it as 4x minus 3 all over 3 times 2x squared minus 3x raise it to the 2/3. Okay. Next page, we are gonna do some logarithmic and then exponential one. So take a look at this. Again, same thing. What are my g and h such that when I compose, I come up with the f? So I'm looking at this. Oh, this is good because I see the parentheses. So that's a good sign that I'm gonna probably let the 12x plus 5 as my h function. So g of x, h of x, so let's start with that, 12x plus 5. But where is 12x plus 5 put it into? Some ln function or 7 times ln. So 7 ln of x will be my g. So that looks good because when I compose g of h of x, I'm going to plug this one into whole thing and I get back exactly the same. So we got the first step. Second step will be taking the derivative of each g and h, and last step we use formula to plug it in. So let's take the derivative. So here, g prime of x, this one recall chapter 3.1. We did a derivative 3.1, 3.2, which is last week material. We learned how to take the derivative of ln x. So this will be 7. ln x is 1 over x, so 7 over x. H prime of x will be just 12. So we are now ready to do the chain rule. f prime of x will be g prime of h of x times h prime of x. So I'm going to take this whole h of x into this wherever you see x. So my first term will be 12x plus 5 over, 7 over, where the x is, 12x plus 5. H of x will be 12. Let's keep going. I can multiply 7 and 12. So 7 times 12 will be 84. 84 over 12x plus 5. Okay. So once you identify g and h, it's pretty simple. Okay. It's just practicing how to rewrite f as a composite function. One more and then last practice, and then we go to an application problem. Now, this is a little bit difficult because I don't see like a parentheses, right? But there's some function. I see the e function and I see kind of like 2x minus 3 function, right? So this is like a power, and it's not just simple e to the x, it's something put it in. So 2x minus 3 will be a good choice for my h, and this got plugged into e to the x, but we have a 7 in front, so 7 raised to the e to the x. If I compose it, will I get this one here? Yes, we put it here on the power, so we get 7 e to the 2x minus 3. That's good. So that's how you kind of check. G prime of x, again, from chapter 3.1, 3.2, last week material, we learned that e to the x is just e to the x. So it will be 7e to the x. H of x will be just 2. Now, let's keep going. So I'm going to have f prime of x, g prime of h of x times h prime of x is my chain rule. So I have h of x going into g prime of x. So wherever you see x, I'm going to replace it with 2x minus 3. So 7e to the 2x minus 3 times h prime of x, which is 2. 7 times 2 will give me 14e raised to the 2x minus 3. Done. Okay, so in a sense, chain rule is pretty simple. I think it's even easier than product and then quotient rule, because product and quotient rule, it's a little bit lengthy. Okay, last one. This is one of your homework problem. I picked that up because the way you enter the answer might be a little bit tricky. So I like to go over how to enter it on my math lab correctly. So I'm going to do just one part. Part A, the 3 hour. 5 hour is the same thing too. Instead of 3, you just pick T as a 5. So I'll do that, and then I'll also do the graph. Okay, so I'm giving you enough instruction for you to complete this. So here, the drug concentrate in the bloodstream T hours after injection is given approximately C of T equal to 3.75 e to the negative T between T 0 to 5, where C of T is a concentration in milligram per meter. What is the rate of change of concentrate after 3 hours, after 5 hours? Graph C function. Well, here I see the word rate of change. You know by now rate of change means differentiate. So that means I need to find C prime of T, but not there at 3 hours. So I'm going to replace 3 after I take the derivative. So let's do that. So c of t is 3.75 e raised to negative t. So I need to come up with a g of t and then h of t, right? Because c of t will be g of h of t. Now, this looks very similar to what we just did here. You have a number e raised to the power. A number e raised to the power. So I'm going to do the same trick. This will be my h. This remaining one will be my g function. So negative t, 3.75 e raised to the t. Don't use x because our variable is t this time. So g prime of t will be just 3.75 e to the t, just like this one here. And then derivative of negative t is just negative 1. So my c prime of t will be g prime h of t times h prime of t. And then we have h of t, plug it into this one here. So we have 3.75 to the negative t times negative 1. In other words, negative, my c prime of t will be negative 3.75. Oops, made a mistake. There should be e. Sorry, I'm missing e. E raised to the negative t times negative 1. So negative 1 times 3.75 give you negative 3.75 e raised to the negative t. Now we want to plug it in after 3 hours. So that's t equals 3. So c prime of 3 equals negative 3.75 e raised to negative 3. So let's get a decimal number. Do not round until final answer. So I didn't round it until final answer. Nearest 100. So 2 decimal place. So let's pull out the calculator. Okay, so it was negative 3.75 e raised to negative 3. I get, it says rounded to the 100th place, so 2 decimal place, negative 0.19. Negative 0.19. That will be final answer. Now, take a look at the options. So it's a multiple choice. Select the correct choice. So here, this is a little bit tricky. So that's why I'm showing you how to enter it correctly on MyMathLab. So first, you have to see that it's a negative notation. So that means the rate is decreasing. Negative notation has to do with the decreasing. So you have to pick B, decreasing. Okay? And then don't put negative because you already can take care of that by putting decreasing. So just put 0.19. And then that will do the job. Okay? So this will be how you enter it correctly. Decreasing, negative, and then just put 0.19. Okay? Part B, graph C. So I'm going to graph this function, and you can use a graphing calculator. So you just pull out graphing calculator, go to y equal to, and then y equal to 3.75 e raised to negative x. And since you wanna narrow down the t between 0 to 5, here's how you rearrange it. You hit the window button and you can change that. The minimum was 0. Maximum was 5. So you do that, hit graph, and this is a graph of your C of t function. And you can copy this and then create a graph. So that will be a answer for part B. Okay, that's it for the chain rule. And then I'll see you guys on next video.